students, this week you are going to be completing 2 different Arduino programs. The first one is called Alt Blink. It's a different version of the Blink program that you did 2 weeks ago, and you're also going to be doing a program called Push Button. Now, in this overview, I'm going to walk through the activity guide with you. I'm going to demonstrate how to add these components into Tinkercad and get them connected, but I am not going to go over the programming with you because the whole point of this is to learn how to program. So, of course, you are welcome to use your resources. The internet has tons of stuff on how to do Arduino programming. Of course, I am here to help you. So throughout this week, you're going to do those 2 programs, get them submitted, and we're going to be good to go. So let's take a look at what we're doing this week. All right, DE students, let's take a look at 4.2.2 Intro to Microcontrollers. So your big concept, you're going to be creating 2 different programs this week, the Alt Blink and the Push Button program. So again, if you would want to, you can download and install the Arduino IDE. You can also code online if you find that to be easier. There is a cloud version. So you just go to the website that I have linked right there, and it will give you access to the actual Arduino coding environment versus trying to code in Tinkercad. So first, let's take a look at the Alt Blink program, where you're creating a modified Blink program. So again, you're going to log into Tinkercad. Make sure you're using the Login to Google option to log in with your MCPS credentials. And then to create the Alt Blink circuit, you're going to need a breadboard, your Arduino, a 220 ohm resistor, and an LED. That circuit looks like this. I apologize, it's a little bit blurry, but you have your Arduino in the center. That Arduino is connected to power and ground. Then coming out of that, it goes into the LED. Make sure you remember that these little babies have polarity. And then it goes out of the LED into the resistor, which is then hooked into this area right here. So you need to make sure that you have this set up before you try and do any of your coding, because when you go to test your code, you're going to have to run it on here to see if it works. Now, you are going to be defining the following, with LED A defined as the resistor on the Arduino and LED B defined as the LED on the breadboard. You're going to make 2 LEDs blink in an alternating pattern. LED A on the Arduino is off when LED B on the breadboard is on. LED A on the Arduino is on when LED B on the breadboard is off. So you are going to have a LED blinking that is physically on the Arduino, and then you're going to have the one on the breadboard. So they are going to alternate, hence why it's called the Alt Blink program. So then after you've completed this, you are going to complete the worksheet. You're going to insert a screenshot of your circuit, copy and paste the code from your sketch. Okay, DE students, I am inside of Tinkercad, and I'm going to show you how to place all of the parts that you need for the Alt Blink circuit. Now, there are very few parts for this, but I do want to make sure that you know where all of them are. I'm not going to wire up the circuit in front of you because you have the image, and I know you guys are capable of doing that. So I'm going to choose Components, All, and I do get a nice search feature, so I'm going to go ahead and type in breadboard. And I'm going to then select the large breadboard, and I'm going to drag it over to here. Now, knowing my luck, Tinkercad is going to lag just like it is right now. So I'm going to fill the dead air by rambling politely about how the breadboard might take a second to load. So just be patient. It tends to happen if you use the search feature. If you scroll through, it seems to be less of an issue. There's my breadboard. So now that my breadboard is there, we are not going to use the search feature again. I'm going to try and scroll. There we go. So I do need a 220 ohm resistor. I'm going to drag and drop again. Tinkercad can be a little laggy, so we're going to take a moment to reflect on why we need a 220 ohm resistor. That is because that is the resistance value that is going to support our LED and prevent it from burning out. If you do not have a 220 ohm resistor inside of this circuit or any other value of resistor, it can have negative side effects on that LED and essentially blow it up. So that is not what we want. So we are then going to double click on that resistor. We're going to change it to 220. Make sure you change the unit to ohm instead of kilo ohm. And there we go. There's my resistor. So I'm going to continue to scroll down through here. Look at all this cool stuff. We are going to grab the LED and bring it over here. Remember that LEDs have polarity. There is a directionality to this. So you are able to change the color of your LED, though I will warn you, if you choose blue or white, it can affect the amount of voltage that it needs. Blue and white LEDs need a little more juice than the other colors. So I recommend keeping it on red because if you change it to blue or white, you may end up with issues with that specific resistor value. Now I am going to continue to work my way down through, and here's my Arduino, which is the last piece that I need. So I'm going to drag my Arduino over. It will eventually populate. And we're going to be patient. Now, you do have the ability to rotate these parts. It is slightly outside of my recording area, but if you click on a part, and it should become outlined in blue once you click on it, again, we've got some good old lag on the Tinkercad this morning. But once you have it selected, there is a rotate button right over here that will allow you to rotate your parts in such a way that you can turn this so the pins line up a little bit neater. If you notice in the picture, that Arduino is rotated. So make sure that you're taking advantage of that rotate tool. You also have the undo and redo. You can see I just got a nice little blip of, oh, hey, it's running a little behind. Be patient. That's all I can say. There are a lot of schools using Tinkercad. I also probably have a little bit of lag because I'm uploading a video to YouTube in the background. So I'm going to ask that you have a little bit of patience. This is not too lengthy of an assignment, and you can easily do the code and then come back to this. But those are the parts that you need for your Alt Blink. So let's go back over to the activity guide and take a look at what else we're doing this week. Okay, so now let's take a look at the push button program. This is where you're going to create a program that reads a push button and turns on an LED. So again, we are logging into Tinkercad and you're using your MCPS credentials using the Login to Google option. You're going to create the push button program by using a breadboard, an Arduino, a 220 ohm resistor, a 1000 ohm resistor, a push button, and an LED. That circuit looks like this. So again, we have the breadboard. We then have the Arduino in the center hooked up to power and ground. Then over here we have the LED. Again, remember your polarity with our 220 ohm resistor. Then going into our push button, we also have a resistor here, and then it comes back out. So make sure you have the circuit set up as you see it here in this image. Now, to create the push button sketch, you have a few constants. Okay, so you're going to define constant integer named button pin assigned to pin 12. And then you have to define the constant integer named LED pin and assign it to pin 2. You also have to define the variable integer button state equal to 0. And then in your void setup, you need to add a pin mode function so that the variable LED pin is an output. And you have to add an additional pin mode function so that the variable button pin becomes an input. And then inside of your void loop section of your sketch, you need to read the input pin button state so that it's equal to digital read, and then button pin in parentheses. Don't forget your semicolon. And then you need to put in two if statements that if the button state is high, it turns on the LED, and if the button state is low, it turns off the LED. So you're essentially creating a circuit that when you push the button and close the circuit, the LED will turn on. When you release the button and the circuit goes low, you then are able to turn off the LED. Again, you are going to complete the worksheet. In the worksheet, you're going to put in a screenshot and then copy and paste the code from your sketch. Okay, DE students, now we're going to take a look at the parts that you need in order to complete the push button program. So again, I'm going to come over here to where it says basic under components, and I'm going to choose all. I know that I need 2 resistors, so I'm going to pop the first one over. One of them is a 200 ohm, or 220, forgive me, a 220 ohm resistor. We're going to put that guy in, and then we're going to drag over a second one, and that is a 1000 ohm resistor. Now you'll notice as you type in different values, you do get those different color bands on the resistor. That's kind of fun. We also need a push button for this one. I'm going to continue to scroll. You may notice that on this round, I didn't use the search and it is going a little bit cleaner. I need an LED. I need a breadboard. That's probably going to take a minute to pop in there because it's bigger. Wow, that was pretty quick by Tinkercad standards. Awesome. And then the last thing I need is my Arduino. So I'm going to drag and drop that in there. Again, you're going to want to rotate these parts so that way they fit efficiently or fit neatly. So I'm going to rotate that around. This is going to allow me to line up that ground and power with ground and power much easier, as well as the different pins that I have to identify in my code. Now, something I did not remind you of in the last parts placement video, you do have a section for code over here. Now, this is different than what you have in the Arduino environment because this does have some drag and drop options. So if you are really struggling with the coding, and typing out all of the different loops is just not your thing, you are able to come in here and you can use the different blocks to do your Arduino. Is this really what I want you doing as a high schooler? No, not so much. I would like to see you taking on the challenge and giving me the code. Also, this is going to have to mean retyping in your document because you can't just cleanly copy and paste this. So give that a whirl. And again, you need to start your simulation, check out your circuit, and then screenshot it and put it into your document. So let's go back over to the activity guide and wrap up our assignments for the week. All right, so now that we've gone over how to put things into Tinkercad so you know where all the parts are located, we've gone over the different components of the programs, you have 2 submissions you have to give to me this week, and that is the worksheet with the screenshots and the copies of your code, and then the circuit, so you have to use that share function in Tinkercad to be able to submit this. All right, guys, that finishes our activity overview for this week. Again, for submissions, you have your 2 worksheets that are inside of Classroom. You are going to be taking screenshots of what you did in Tinkercad, as well as copy and pasting your code into those worksheets. Additionally, you need to give me a link to what you've created in Tinkercad and attach that inside of Google Classroom. So make sure that you've done all of that, hit submit. We've got 2 more Fridays to go, including this one. So just finish strong, guys. We're almost there. And I will talk to you soon.